Scholars, my name is Miss Meyerson, and I'm the sixth grade math teacher at Linden Middle School. Today, we're going to be doing Unit 8, Lesson 4, the area of acute and obtuse triangles. We're going to be building off of what we learned in our last lesson. We've found that the area of a right triangle is half of that of a related parallelogram that shares the same base and height. And we came up with two formulas that we could use. Area equals half base times height, or area equals base times height divided by 2. Today's question is, how can we find the area of any triangle? Take a moment to review some of our key vocabulary from this unit. There's a review of triangle vocab if you need to remember how to categorize triangles. Let's keep going. Here are the 4 triangles we're going to be working with today. We're first going to pause to give you time to sketch each of these triangles on your paper. As you sketch them on your paper, what do you notice about these triangles? And what do you wonder? Today's Grapple task. Feel free to make annotations as I read. Find the area of each triangle using area reasoning strategies. That could be decomposing, composing, duplicating, or rearranging. Show your thinking on paper. We're going to pause here so you can sketch out a plan of how you'd find the area of each of these triangles. It might take more than one sketch, so feel free to try again if your first try doesn't work. One of the most common ways to do this is to create a parallelogram like we did yesterday. We're going to be using a tool to help us do this. So the first thing when you use this tool is I want you to create the triangle to the best of your ability that we're working with. There. Maybe a little bit smaller. Yeah, now it looks like it has that right angle. Then you can use the slider. It's going to duplicate it in green. And then as you slide, you can see it rearranging. And boom. As you use this tool, I want you to think about how is this going to help us find the area of the triangles. Your teacher's going to share the link with you in the chat, or you can find it below. You might have noticed that as you duplicated each triangle and rearranged it, it created a parallelogram. Depending on what you chose to be the base of the parallelogram, you could have come up with 2 different parallelograms for B. C, when you duplicated it and rearranged, you got one of these 2 parallelograms. And D, again, when you duplicated and rearranged, it created a parallelogram. I think you probably are starting to have an idea of how you can find the area of a triangle, whether it's a right, acute, or obtuse triangle. Let's pause and reflect. How can we find the area of any triangle? Take a moment to write your answer down on paper. The area of any triangle can be found by finding half the area of its corresponding parallelogram. You might also have had a key idea about duplicating a triangle and rearranging it to form a parallelogram, or you might have also included that we know the parallelogram's area can be found using area equals base times height. Now that we know that the base of a triangle and the height of a triangle is important, let's dive into the next part of our grapple. As I read, feel free to make annotations on your page. Identify and label what is the measurement of a base and height of each triangle. Can we use the formula area equals base times height divided by 2 to find the area of each triangle. Why or why not? We're going to pause here to give you some time to work on your paper. Before we reveal the answers, there's a really cool online tool that we can use to check this. I'm going to model first, and then you're going to get to use it. With this tool, you can count the squares. If you thought the height was 2, I'm going to pull that down, and as you count 1, 2, 3, 4, 5, 6, 7, 8, pull this out to 8, and then you can use the green dot to change the angle. This looks like our triangle A. On the top, you can then use the slider to create a parallelogram. You can see the triangle duplicating and rearranging. If you said for A, the height was 2 units and the base was 8 units, you are correct. We're going to pause here so that you can use this tool. Let's check your work. B created a parallelogram that looked like that. So you can see the base that we could have drawn was here, and the height was there. That is a base of 7 units and a height of 3 units. For C, when you duplicated the parallelogram, looks like this. If you chose the bottom as the base, it would be a base of 5 units, and the height was 4 units. This last one was a little tricky because if you had it lined up on the squares to use this, you had to rotate the whole triangle. So I turned the triangle on its side, and I said if this is the base, I can count 4 units on the graph paper, and then perpendicular to that is 6 units. Remember, the base can be any side, as long as the height makes a right angle with that base. But creating a parallelogram is not the only way to look at this problem. Let's look at a different way you could have decomposed our triangles. For triangle B, we could cut this triangle into 2 smaller right triangles. You can see the first right triangle is on the left side, and the second one is on the right side. Then you can use this tool. We know this one has a base of 7 in all, and it has a height of 3. And then this needs to come over a little bit. So as we look at this, we have 2 right triangles. The right triangle on the left, we could draw a rectangle by duplicating that right triangle, rearranging it up here like we did in our last lesson, and say this one has a base of 1, 2, 3, 4, 5, and a height of 1, 2, 3. And then we could say the right triangle on the right has a base of 1, 2, and a height of 1, 2, 3. We could find the area of each of the smaller right triangles and then add them together to get the area of the total triangle. If you prefer the parallelogram strategy, that works just as well. Some scholars might prefer decomposing into 2 right triangles. Also, different triangles might have different strategies that you see more quickly. Feel free to play around with this tool and create different triangles, adjusting the height and the base to see how you would use it. Study the examples and non-examples of bases and heights in a triangle. These are your examples with the dash segments, and these are your non-examples. Based on the examples and non-examples, explain what you know about the base and height of a triangle. A base can be any side of the triangle, as long as the height is drawn to make a right angle with that side that you've designated the base. The height is the shortest distance from the base of the shape to the opposite side, or opposite vertex if it's a triangle. The height is perpendicular to the base. Here are 3 examples of base and height. We normally put the base as the bottom, but these are great examples over here of how the base could actually be any side of the triangle. And then once we pick a different base, the height then is going to be different. All 3 calculations are going to give the same area for the triangle. Again, you can see the base could be the bottom, the right, or the left side. When you choose a different base, you're going to choose a different height to make a perpendicular line that goes from there to the opposite vertex. For each triangle, circle a base and a height measurement that you can use to find the area of the triangle. I'm going to pause here to let you show your work on paper. Let's check our work. For A, 5 centimeters at the bottom had to be the base, and 6 centimeters was the height. For B, either one of these could be thought of as the base or height. It doesn't matter in a right triangle. You can check the rest on your own. If you have any questions, feel free to check in with your teacher. Let's reflect on what we have learned in today's lesson. How can we find the area of any triangle? Take a moment and write your answer on the paper. Our key idea for the day is that you can use the formula area equals half base height, or area equals base times height divided by 2 to find the area of any triangle, not just right triangles. Any side can be a base, and that the height is a segment that is perpendicular, meaning forms a 90-degree angle to that base and the opposite vertex. Make sure you're writing down your formulas as you dive into your independent practice for the day. Good luck.